Hi everyone, I'm going to explain to you in 5 minutes the basic principle of ionisation and how this links to the properties of alpha, beta and gamma. You can get free access to this original PowerPoint presentation made by myself, as well as other similar resources which are really useful for students and teachers to help explain some tricky physics concepts. Just follow the guidance in the description below. So we have ionisation. So what we've got is an incoming alpha particle. We have 2 protons and 2 neutrons here, and this has energy and momentum, and it collides with an atom, and we would assume the atom is neutral, which means there is the same number of protons and electrons. So we have lots of energy. The alpha particle collides with an electron and knocks it out. So we have lost an electron. We have created an ion. The atom, which was previously neutral, now has a positive charge because it's lost a negative charge. The alpha particle no longer moves, it's lost its energy, so it doesn't really do anything from this point forward. But the ejected electron can cause further problems. Right, so what is the significance of this with alpha, beta and gamma? So, as I'm sure you know, alpha, as we've just said, is made of 2 protons and 2 neutrons. A beta particle is just a fast-moving electron, and a gamma wave is just a wave of electromagnetic radiation. So we need to think about how does each of these 3 types of radiation interact with matter, how much ionization does each one cause, and how is that affected, or how does that affect the range of each. So let's have a look at alpha first of all. So alpha has got the largest mass and the largest charge, even though it tends to be moving the slowest. So because of this large mass, large momentum and large charge, it causes lots and lots of ionization over a short range. So we have this short range, but lots of ionization. Okay, so let's think about a beta particle. So a beta particle is much smaller. It has a smaller charge, just a charge of -1. So it interacts with matter less readily. It causes less ionization, therefore you could say less damage perhaps, but it travels further. Finally, we have gamma radiation. This has 0 mass and 0 charge, and it travels very, very quickly at the speed of light. So it passes through most of matter and doesn't really interact with matter at all. So it travels much further before it causes ionization. So it's got a larger range. So here we have this link between the properties of alpha, beta and gamma and how they're related to the amount of ionization each causes and the range as well. And this leads into discussions about which is the most dangerous. Well, it depends on the situation and the exposure and the proximity. So yeah, as I said at the start, if you want to get this PowerPoint, the original version, so you can play around with it and move it at your own time, I think it's a really useful resource for teachers and for students. I hope you enjoyed the video.